Welcome to another episode and video on my walking robot Mirft2, which is based on the fischertechnik TXT controller running embedded Linux and in online mode programmed in Python. It has on front two touch sensors as well as a USB camera for use with OpenCV. And another switch or sensor next to the battery. Last time I thought it was a nice way of testing on distance or counter of the motors to use a scaffold. So I have created a scaffold from last time, and the difference I hoped was to see whether the weight of the robot was indeed a major factor, a major issue on the distance it walked. And last time it turned out it was, but results vary, as I have learned as well. So first of all, let's run the script, the program, the Python program, and then I do hope that I don't get an error right away. I know I get lots of errors on network, on OpenCV, but right now it does go quite okay, well in program running, but it doesn't really walk. And then this sound happens saying okay, end of the algorithm. So, but I haven't seen it move, and yet it gives 5 and 4 as counters, and distance. Counter should go up, distance should go down, because apparently the distance you set for the motor is the distance towards the end, and the closer you are, the smaller the distance. So it is the distance to the finish and not the distance from the start. And yet it doesn't really work. So let's add the scaffold, being careful with what it's. So that is the scaffold. Let's see whatever happens this time. If something happens. Camera connected fine. And there you see. So, and now the distance is 1. And I did do an adjustment in the distance to walk. And the distance was set to 8,000. Well, last time I also tested for 4,000, and 8,000 didn't seem to have a very large impact. It walks the same amount of time, the same amount of distance or time or whatever. So something is not quite right. Anyway, further experiments to come. So let's see how. Alright, so talking about distance, how to measure. I can measure the time it walks. I can also measure the amount of cycles. How many times does one of the gears rotate around its axle, around the axis? So let me take this gear. How many times does it walk? Does it go around? With 4,000 or 8,000 or 12,000? And let's go here to distance, and we say first go back to 4,000. So and let me see first. This is 0. Okay, doesn't matter. Okay, I can't reset anything, so let's just go. One, 2, 3, 4, 5. Well, I said 1 here, but that was all obviously half. 1, 2, 3, 4, 5. Let's say 4.5, but I don't care. Let's count again. When it ends up here, although 4,000, yeah, what's up? Okay, let's do it again. When it comes here, it's 1. One, 2, 3, 4, 5. It's 5. Okay. That means that 4,000 equals, or yeah, it's 5. Let's go then to 8. Alright, go. Again, how many cycles? 1, 2, that's not even 2. Test again. One, 2. That is not good. Third time. One, 2. It's 2.5. About 8,000 is about 2.5. We go to 2,000. Go. One, 2, 3, 4, 4 something. Again. 1, 2, 3, 4, 5. Another one. One, two, okay, here is clearly something wrong with the left and right side. But how can I do that? Here, can I do something here? It's completely zero, so I can't do anything. Okay. Do again for 2000. One, two, okay. This is as inconsistent as can be. So I can't even write a result. Let's go back to 8. See if I get 2.5 again. No, 4. No, 8. 8 it will be. See whatever the result is. One, two. Well, that is about same thing, yes. Let's do it again. One, two, 2.5. Well, that's exactly the same as the first time testing. So, what else can we do? 16. Or I haven't tested 6, by the way. Let's test 6. So 4000 is 5, 8000 is 2.5. In between, it's 1.5. No, it's 2.5 difference. That's so my estimate, my prediction. My prediction would be 3 something, 3 cycles. Yeah, that would be 3.25 cycle. So let's see if that works out. Here and ending here somewhere. One, two, that's not even close. And 1, 2, 2.5. 6000 is 2.5. Yet another time. One, two, 2.5. So 6,000 equals 8,000 being 2.5. Not really what I expect, but then what? Then, according to my information, which came to me from the firmware developer, he said if you set the distance to 0, then it will be an infinite something. So let's do that. Let's put things to 0 and see how many cycles it does. One, 2, 3. Oh, really? That is 3 something, 330 something. 3.3. Let's do it again. One, 2, 3. 3.3 again. Another one. Going from here. 1, 2, 3. Well, there's not even 3, that's 2. Okay, yet another one. Oh, this one. One, 2, 3, 3,3. So if I count the distances, and that goes about this, then 1, 2, 3. That's the most it will get. This is the do I have some other measurement? I do. So let's say this is the distance it walks, and then times 3. This is 5 centimeters. You get 15 centimeters to walk. Plus a third is something like 18. So given the distance, it walks for 18 centimeters. No more, no less. Right, let's test again. Oops, that goes to scaffold. Yeah, and now you can, and then this happens. Unscheduled, but nice to see that the weight prevents the legs to run. So let me get it back on the scaffold. Yeah, it's not a very robust one. I don't care. Alright. Let's go on. Measure the distance it walks. And it should come here somewhere. Yeah, that's 5 centimeters indeed. So 5 centimeters from there times 3 is 15. It's enter out there, and that is with an infinite with an infinite distance. So something is not quite the way I expect it to be. Alright, let's increase the distance to well, 4860. Let's go to 10,000. This is 10,000 and this is 10,000. Yes. I am very curious how it will go now, because the higher the shorter the distance, it seems. So we go to 10,000, which equals then 1, 2, that's 2.5. Another one. One, 2, slightly more. That's 275. Another one. One, 2, 3, 4, 5. That's 5.3 about. Next. One, 2, 275 something. Okay, that's not quite consistent. But what to do about it? That's the biggest question. Yeah, some thoughts. So with these inconsistent results, let's take the maximum walked distance of 5.3 with the 10,000. With one distance is one cycle is 5 centimeters, so that would be 25 centimeters. That is this. and it was actually 5.3, so let's say 26 centimeters. Given the fact that it walks but it has these sensors as well, then it should stop at a certain distance. So what is this distance? It's 10 centimeters. So with these sensors it would not go the full distance. 2.5 is what I'm, now let's say 4000, then I measure 5 cycles. 5 cycles is 25 centimeters. Would I get that? Minus 10 is 15 centimeters walk. What is the difference? Oh, there we go again. On the scaffold, well, let the scaffold be for now. So 5 is 25, minus 10 is 15. What is the distance? Is about 15. So on 4000 it would reach these objects. If, because with the scaffold, and let's go back to 4000 then. No scaffold. That's 1/3 of a distance. Another one. Yeah, right. Enough said. More than enough said. This is something that asks for 2 more motors and a redesign at least, because this is never going to work out. And you don't want a walking robot on the scaffold. That's for sure. Ouch. And with these remarkable results, I'm at the end of this episode. So, yeah, reconstruction of the robot is absolutely necessary, but I lack the motors for now. Also, when on scaffold, there's no consistent behavior in the number of, or the expectation of distance. So it needs to be researched further when applied to. Thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, and leave a comment if you like. Much appreciated. You can also follow me on Twitter. If you do, please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. If you appreciate my videos, then please consider a donation, small donation. And you can also choose to become a patron and have your name mentioned as a supporter. Either just on my website or on my website as well as with my videos, depending on the pledge you make. For now, Thank you for watching and bye bye.